Welcome to Mrs. Carl's Chemistry Crash Course. Today we're going to be talking about isotopes. Before we talk about isotopes, let's take a quick little tour of a block or an address on the periodic table. So here's a block of carbon. So this is what carbon could look like on a periodic table. All periodic tables are slightly different where they put information, so you want to look for a key on the periodic table when you get one or get a new one to figure out where the information is. So the first little bit of information that you're going to want to notice is right here in the middle, the atomic symbol or the chemical symbol. Some of them will have the name with it, but the chemical symbol and the name will tell you what element it is, part of the information that tells you. On this block, up in this corner, this number is the atomic number. That is of utmost importance. That tells you also what element you're dealing with. Each element has its own specific atomic number. If that changes, the element changes. So carbon cannot have an atomic number of 7, cannot have an atomic number of 32. So the atomic number of carbon is 6. That number tells you the number of protons in the nucleus. Okay, so the number of protons is what the atomic number is going to tell you. And then generally somewhere near the bottom you have that number, that's a decimal number, that's the atomic mass. Okay, the atomic mass is a weighted average of all the naturally occurring isotopes. So that's covered in another video if you'd like to learn more about atomic mass. But atomic mass is always a decimal number, and it takes into account all of the isotopes. So let's talk about what isotopes are. So an isotope is an element that has the same number of protons, but a different number of neutrons and a different mass number. So let's look at some examples of isotopes. Okay, let's look at 3 isotopes of carbon. So this is one way to write an isotope, where you write the name and then a dash and then what we call the mass number. So let's talk for a moment about this 12, 13, and 14. So this is called the mass number. And the mass number is simply the number of protons plus the number of neutrons. So that's going to be very important when we need to figure out some of the subatomic particles and how many we have. So our mass number tells us the number of protons plus the number of neutrons, and you'll get the atomic number off of the periodic table. Another way you can see these written, in a way that I prefer, it's kind of easier to see the information. They'll write the mass number up there, and they'll write the atomic number below it. So then you have a lot of information on that, and you don't have to look a lot of information up, or it's kind of easier to figure things out. Well, I guess that first carbon should be carbon 12. Let's try that again. Put carbon 14 down here. Okay, so part of what we want to do with isotopes is figure out how many protons, how many neutrons they have. So now let's take our isotopes and figure out the number of protons and neutrons. So this number, notice is it's 6. If we had a periodic table, we could look that up and find out that that's our atomic number, which means that's the number of our protons. So in this isotope of carbon, carbon 12, we have 6 protons. Now, if the mass number is the protons plus the neutrons, and our mass number is here on top, that's our mass number, and that's protons plus neutrons. To figure out neutrons, we're just going to subtract our protons from that. So in this isotope, we have 6 neutrons. See if you can anticipate the next isotopes before I get to them. Carbon 13. Again, our atomic number is right there on the bottom. So we have 6 protons. Subtract that from our mass number here on the top, and we get 7 neutrons. And for carbon 14, there's our atomic number there on the bottom, so that's our number of protons. And on the top, we have our mass number, 14. So if we take 6 from 14, the number of neutrons we have are 8. So there's our carbon isotopes. If you notice, they all have the same number of protons. Same number of protons. So each of them, because it's carbon, they have 6 protons. And notice they all have a different number of neutrons. This one has 6 neutrons, this one has 7, and that one has 8. And if you look at their mass numbers, they have different mass numbers. So that's a little bit about isotopes. Hopefully that helped you out. Thank you very much.